the previous video, we looked at adding or removing chemicals and the impact they have on an equilibrium, how that stress can cause something to shift. So with another equilibrium here, if I put more nitrogen into a container, then I would have too much of that for the relative amount. The nitrogen, the extra nitrogen would react with hydrogen, making more ammonia. It would shift to the right. However, if I remove some hydrogen gas, now I wouldn't have enough of that. I would need to make more of it. And the thing that makes more of it would be the ammonia. So the ammonia would be breaking apart. It would break apart to make more hydrogen. In doing so, it would also make some more nitrogen. We would have less of this. But in all of that, whether we're adding or removing, we get back to that same ratio. Whether we have more or less of exact things is not important. The important thing is that our ratio or our K value is the same. Another way that we can stress systems is by increasing or decreasing the pressure, which can happen by increasing or decreasing the volume. So sometimes it's described either way. I like to think of it in terms of volume, but pressure we know is the inverse of volume from Boyle's law. When the pressure goes up, the volume goes down, or when my volume goes up, a bigger container, fewer collisions, so less pressure. But pressure only impacts gases. So if our equilibrium involves solids, liquids, or aqueous, we don't look at those at all to see how changing the pressure or volume would impact or would cause our equilibrium to shift. Both of these have underlined moles of gas, and that's the only thing we're going to look at. So here, the right side says decreasing the pressure, which is also increasing the volume. We now have a larger container. When we look at our reaction has 1 mole of nitrogen and 3 moles of hydrogen on the left side, or the reactant side. It has 2 moles of ammonia on the product side. When I have a larger container, that is more space to fill. The side or the chemicals that can fill that space more effectively is the side that has the most gas, or the left side. So an increased volume shifts to the side with the most gas. In doing that, the molecule or the side with fewer moles of gas goes away so that we can then better fill that container. The math supporting this in terms of Q and K with KPs and KCs sometimes is a little bit tricky. So thinking about it like this is probably the best or most important way. Remember, big volume means most moles of gas. So then small volume would be fewer moles of gas. And big volume, it goes to the left. Small volume, it goes to the right. But then we also can connect that to what does that mean for pressure. An increased pressure, that's like a smaller container. We shift to the side with fewer moles of gas. The larger container results in a decreased pressure, and we go to the more moles of gas.